Lesson 79, Systems of Equations with Subscripted Variables. We talked about subscripted variables not too long ago when we were talking about nickels and dimes and quarters, and we used the subscripted variable that looked like this. This was the number of nickels, this was the number of dimes, this was the number of quarters. And you can absolutely read those variables like that. But another way to read subscripted variables is to say n sub n, n sub d, and n sub q, especially when it gets more complicated and you have more variables to deal with. For instance, we are given some variables here where we are talking about rates of speeds and time, and rather than use unusual variables like x, y, and z, where we have to turn around and figure out, okay, well, what was x again? What was y again? We just use a subscripted variable to keep us from having to keep up with a legend or a key to what those variables mean. So for instance, if I want to say the rate of Anne, I could say r sub a. I could read the rate of Anne, or I could say r sub a. I might not know. I might be looking at somebody's homework and I might not know what the rate of Anne. I might not know that, but I can see that RA goes together. So I can just say r sub a and it makes perfect sense. I can keep that variable together. Also, it will allow you to link certain variables. For instance, if Anne has a specific rate of speed and then Anne also has a specific time that it took her to do that rate of speed, then, or the time she was doing that rate of speed, then I could say time sub a, or the time of Anne. And you know, if you take the rate of speed, the rate of Anne times the time of Anne, then we could get, the distance of Anne, for instance. I'm not sure if that's the right formula, but that will help us to identify which ones are Anne's and which numbers we're talking about and how they relate to her. So sometimes when we read a word problem, we don't always have to use x and y and z for different variables. We can relate them together by using this subscripted variable here. So we are given this problem. I'm going to show you how to use subscripted variables. We are given the rate of Anne times the time of Anne plus the rate of Pat, this is r sub p, times the time of Pat, which is t sub p, that equals 320. We are told that the rate of Pat was 50. And we are told that the time of Pat was 4. And we are told that the time of Anne was 3. So we can drop these in just like any other substitution problem. So the rate of Anne is what we don't know. So we have the rate of Anne, and it's times the time of Anne. So we're going to put 3 right in here, or make our bucket. And now we're going to make these buckets, RP and TP. We're going to drop RP and TP into our buckets. Okay, so we're left with 3 rate of Anne plus 200 equals 320. We're going to swim some fish. And that's going to give us 3 times the rate of Anne equals 120. So now all we have to do is divide both sides by 3. And the rate of Anne is 40. Sorry, I've been talking a lot today. So now we know what the rate of Anne is. All right, that was example 79.1. So you can see these are just another variable. That's just all they are. We talked about that before. They're just a little bit more descriptive. They allow you to take the words from your word problem and create a variable that you can just look at it and know what it is. Okay? That's all a subscripted variable does. Let's clear this. Moving a little slow today. Let's do 79.2. We are asked to solve the following system of equations for TR and TT. So solve for T sub R and T sub T. Okay, so we have RT, TT. Oh, sounds like somebody gonna have an accident there. Plus 120 equals RR and TR. We are told that RT is 2 and that RR is 10. Okay. And we are told also that T sub T is equal to T sub R. How about that? So if we're going to solve for T sub R and T sub T, and we know that they are the same variable, the same value, we can just rewrite this with a different variable. We could say R sub T, TT, plus 120 equals R sub R, and just put T right here because it's the same thing as TR. It's the same value. We're just going to sub that in. Okay. Now, oh goodness. What was RR? That was 10. My pen did not work on that one, did it? All right, now we can drop in our buckets. We have RT. So here's a bucket. And we know that's 2 times T sub T plus 120 equals R sub R is 10 times T sub T. I can get rid of these parentheses. They're not doing any good because it's 2 times T sub T anyway. All right, now we can swim fish. So I'm going to take the 2 and swim it to the other side. So that cancels. 120 equals 8 T sub T. And 120 divided by 8 is going to be, let's see if I have that right so far, going to be 15. So dividing both sides by 8, 15 is equal to T sub T. And since T sub T equals T sub R, we know that T sub R also equals 15. Okay? And just in case you're wondering, you do have a keyboard option for Subscript. You do have one. It's on your Algebra keyboard. So you can make a subscripted variable in your answer if you need to. That is not out of your realm of possibility. All right, we have 2 more. Let's go through those. You can see these are just more variables. That's all they are. 79.3 says to solve the following system of equations for T sub L and T sub S. So we want to know what is T sub L and T sub S. Right, and here is our equation. We are told that R sub L times T sub L equals R sub S T sub S. We are also told that R sub L is equal to 40 and R sub S is equal to 80, and that T sub S is equal to T sub L minus 5. So now we see how we need to substitute. let's put in our buckets. We have R sub L is 40 times T sub L. And then we have R sub S, which is 80, and T sub S equals TL minus 5. So we can put in T sub L minus 5. All right, so 40 T sub L is equal to 80 T sub L, and 80 times a negative 5 is going to be a negative 400. Okay, I didn't put my 0, did I? There we go. All right, so let us swim some fish. I'm going to swim 80 over to this side because 400 is already over here. And I don't know why I'm writing so crooked. I think it's because my I'm sitting funny next to my tablet here. Yeah, that's better. All right, so that leaves us with a negative 40 T sub L equals negative 400, right? When we divide both sides by negative 40, we find that T sub L is equal to 10. And since TS is TL minus 5, 10 minus 5, T sub S is equal to 5. Okay? Stands to reason. Let's do 79.4. I hope you guys find this as easy as I do and that you're not struggling with it. If you are, please contact me. That's what I would like for you to do. All right, so let me see if I can shift here. We are given that we need to look for R sub F and R sub E. We don't know what those are. And we are given this equation that R sub F T sub F is equal to R sub E T sub E. My computer is doing something wonky. I don't know what it's doing. So we are also given the values for T sub F, and that equals 16, and the value for T sub E is 12, and the value for R sub E is RF plus 15. All right, so let's drop in our buckets. We have R sub F times T of F. All right, so that's 16. I'm just gonna go ahead and do it like this. 16 times R sub F equals. And we have R sub E, which is RF plus 15, times T sub E, which is 12. So I'm gonna say 12 times RF, R sub F plus 15. Okay, everybody see how I did that? TE is 12 and RE is RF plus 15. So I just reversed them because we can do that because of the commutative property of multiplication. We can move things around. I just like to have my whole number in front of my parentheses, that's all. And I did the same thing over here. I took the TF, which was here, and put it in front of the RF because that's the unknown, because that's just the way I like to see it. I like to see whole number and then the variable. You can do that because of the commutative property of multiplication. You can rearrange and still get the same answer. And that is why we learned that property, to help us out later on so that we know how to arrange our stuff in a way that is meaningful to us to help us solve a problem. So now let's do the distribution. So that's going to be 12 RF, R sub F, I should say, plus, that's going to be 180. I'm going to swim this fish over to the other side. That cancels. That becomes 4 R sub F equals 180. So R sub F equals 45. Because 180 divided by 4 is 45. All right, now that I have R sub F, I can put it in for R sub E. So R sub E equals R sub F, which is 45, plus 15. So R sub E is 60. Okay, so can you see how these are just more descriptive variables? That's all they are, but they're just variables. They just look a little bit more complicated. All right. All right, that is all we have for lesson 79. So do your practice problems, do your homework assignment, and I will see you on lesson 80.